Welcome to The Explainer. You know those squiggly lines you always see on the monitors in medical shows? Well, today we're going to demystify them. We're talking about the EKG, and we're going to break down exactly what those lines mean and how they tell the incredible electrical story of your heart. Our story starts in a pretty weird place, with a frog's leg. Back in the 1790s, a scientist named Luigi Galvani found that a little spark of electricity could make a dead frog's leg twitch and dance. And this simple, kinda strange experiment, it revealed a massive truth that would completely change medicine. Our bodies are electric. So that first discovery led to another big aha moment. A few decades later, in 1855, some other researchers noticed that if you put that same frog's leg on an exposed beating heart, it would kick perfectly in time with every beat. And that was it. That's what proved the heart generates its own electricity, which paved the way for a guy named Willem Einthoven to invent something truly revolutionary. So in 1901, Einthoven builds the first real, practical electrocardiogram, or as we know it, the EKG. For the very first time, doctors could actually capture the heart's secret electrical story on paper, one beat at a time. So, okay, let's learn how to read this thing. A normal EKG tracing is really made up of three main parts. Einthoven just gave them simple names: P, QRS, and T. You can think of these as the alphabet of a single heartbeat. Each letter tells a very specific part of the story. The whole story starts with the P wave. See that first little bump? That represents the electrical signal that's spreading across the atria. Those are the heart's top two chambers. It's the signal that tells them, okay, contract now, and push blood down into the ventricles. And next up is the main event, the QRS complex. This is the big, sharp spike that everyone recognizes. This is the massive electrical surge that zaps the ventricles, the heart's main power pumps. This is that powerful contraction that sends blood shooting off to your lungs and to the rest of your body. Right, and after that huge squeeze, you get the T wave. This wave shows the ventricles electrically resetting themselves. They're recharging, getting ready to go again for the very next beat. So that's the complete cycle right there. P, Q, R, S, T. The top chambers contract, the bottom chambers contract, and then the bottom chambers reset. Simple as that. Okay, so now that we know the letters of the alphabet, let's start learning how to read a word. And we're going to start with one of the most basic but absolutely crucial pieces of information you can get from an EKG, the heart rate. So for most healthy adults who are just resting, their heart is going to be beating somewhere between 60 and 100 times a minute. We call this a normal sinus rhythm because it's being set by the heart's own natural pacemaker. But how in the world can we figure that out just by looking at a strip of paper? Well, you don't need a fancy calculator or anything. There's actually a brilliant little shortcut for this called the triplet method. The first thing you do is find an R wave, the very tip of that big QRS spike that lands perfectly on one of the heavy grid lines. And then you just count off the next heavy lines using this sequence: 300, 150, 100. And if it's slower, you keep going: 75, 60, 50. Whichever number the next R wave lands closest to, well, that's your approximate heart rate. It's a really simple trick to memorize, and it gives you a surprisingly accurate rate in just a couple of seconds. Now, measuring heart rate is really useful. But this next part, this is where the EKG becomes a true lifesaver. Its real power is in spotting abnormalities, things we call arrhythmias. These are the moments when the EKG tells us something might be going wrong with the heart's electrical wiring. Take a look at this, for example. On the left, you've got a normal rhythm. See how the R waves are all nice and evenly spaced? That rate is about 75. But now, look at the strip on the right. The R waves are way farther apart. If we used our little triplet method, we'd find the rate is well below 60. That's something called bradycardia, a slow heart rhythm, and the EKG makes that difference instantly and obviously clear. And this really gets to the heart of the matter. The crucial point is that an EKG gives doctors a view into the heart that they just can't get any other way. It can pick up on these tiny electrical problems that a stethoscope or just feeling for a pulse would completely miss. It is an absolutely vital tool. So let's just step back and bring this all together. What is it that makes this simple machine, which turns invisible electricity into a language we can read, so incredibly powerful? I mean, think about it. We've seen how the EKG translates the heart's invisible electrical story into a visual language. We've learned that every single part of that tracing has a specific job. We've even learned a quick trick to check the heart rate. And most importantly, we've seen how what looks like just a bunch of squiggles can tell a profound story about health, giving us the power to listen to what our hearts are trying to tell us. So now that you understand the basic language of the EKG, it kind of makes you think, doesn't it? Every single beat of your heart, happening right now, this very second, is telling its own electrical story. What is yours saying?